Atoms and molecules are very tiny particles. So they have very little masses. Their masses, when expressed in normal units like kilograms, grams, or milligrams, we get very small values. So we have to write them in scientific notation or as decimals. Then the decimal numbers will have large number of zeros, so that using them in chemical calculations, when we do calculations, in those calculations, those will make big problems when calculating, because to use those numbers, since they have very large digits, large number of digits, so that using them will be difficult in calculations. You can see that mass of an iron atom is written in the standard form as 9.2733 into 10 to the power minus 23 grams. So it's a very small number. If it is written in the decimal form, you will have to write a large number of zeros. So using this, something like this number, using in calculations will make a lot of problems. So that will be very difficult. As an example, say that you want to find the number of iron atoms in 50 grams of iron. So that we have to divide the mass of iron by the mass of one atom of iron. So the calculation should be done in this way. So that's something very complex. To avoid such complications, we can use a relative method. A relative method means first we decide a mass as the unit. Now, as an example, if I take this pen as the unit, right? My unit is the mass of the pen. So if I have a bottle here, and if I have a pan balance, the pan balance is something like this. We all have seen that pan balances, two pans are there. So one side you can put the units or the weights, the other side the object. So that if I want to place this, if I want to measure the mass of the bottle, I can put it here and say that I want such 4 pens to balance it, so that I can call the relative mass of the bottle relatively to the pens 4. So the relative mass of the bottle is 4, since I needed 4 pens to balance it. So the mass of one pen is the unit that we use to measure the mass of the others. So that if I put one pen this side, so to balance, the pen should be put here. So the relative mass of a pen is 1. As we discussed, since the masses of the atoms are very small, we use a relative method for that. As I explained in previous example, using the mass of the pen, the chemists use relative atomic mass. So here we have selected a particular mass. We know that carbon, if you take carbon atomic number of carbon is 6. The mass number is 12, so that carbon has 6 protons, 6 electrons, and 12 minus 6 gives the number of neutrons. So number of neutrons is 6. But we know carbon has other particles like these. 6 is the proton number. The atomic number, again, the number of protons is 6. Here also 6. So same element but different mass numbers means different number of neutrons. Here the carbon atom has 7 neutrons. Here 6 neutrons. Here 7 neutrons. Here 8 neutrons. We call them the isotopes. We call them isotopes. So we can call this one carbon 12 isotope, carbon 13 isotope, carbon 14 isotope. So we select this one, carbon 12 isotope, but the unit is not the mass of carbon 12 isotope. It is not the mass of one carbon atom. The chemists have decided to select 1/12 of the mass of carbon 12 atom. As an example, if this is the carbon atom, not this mass, they have divided this into 12 parts, and that small one part is taken as the unit. So the unit is 1/12 of the mass of an atom of carbon 12 isotope. 1/12 of the mass of carbon 12 atom. In other way we can say 1/12 of the mass of an atom of carbon 12 isotope. This is called the relative atomic mass unit. Since we use this to compare the masses of the other atoms, we call this the relative atomic mass unit. Here, relative atomic mass of an element, this is the abbreviation for relative atomic mass. So the mass of an atom of the particular element should be divided by our unit. Our unit is 1/12 of the mass of carbon 12 atom. So this is the ratio between the mass of an atom and the unit. Since it is a ratio, we don't have any units for that. So as in previous example, the bottle had a mass of 4. 4 means relatively to the mass of the pen, the mass of pen. So that relative mass of the bottle was 4. Like that, mass of an atom when divided by our unit, you get a value only because it is a ratio. That is called the relative atomic mass. Here this shows the relative atomic mass of calcium. Mass of a calcium atom is divided by the selected unit, our unit, relative atomic mass unit. So that relative atomic mass of calcium is given as 40. So what's the meaning of this? The mass of a calcium atom is 40 times the mass of 1/12 of the mass of carbon 12 atom. The mass of calcium atom, when compared with the unit we selected, is 40 times. So we call relative atomic mass of calcium is 40. Relative molecular mass. This is similar to the relative atomic mass, but here now we consider not an atom, a molecule. So a particular molecule is considered. Mass of the molecule is divided by the mass of the molecule is divided by the atomic mass unit, that is 1/12 of the mass of 1/12 of the mass of carbon 12 atom. That's a relative molecular mass. This is how the relative molecular mass is found. Now here a relative molecular mass of water is going to be found. We are given the relative atomic masses of hydrogen and oxygen, and we know the molecular formula. So here you can see that there are two hydrogen atoms. The relative atomic mass of one hydrogen atom is 1. So such two are there. So 1 into 2. To that, one oxygen atom is there. So that is 16 into 1. So 2 into 1, 2, 16 into 1, 16. So you get the value as 18. So 18 is the relative molecular mass of water. Two compounds are shown here. This is ammonia and this is sodium chloride. Ammonia is a covalent compound, while sodium chloride is an ionic compound. So when ammonia is considered, we use relative molecular mass. Relative molecular mass. Since ammonia contains discrete molecules, discrete ammonia molecules, right? So in ammonia, the molecules are like this. Discrete molecules are there, ammonia molecules, nitrogen, hydrogen, hydrogen, like that. But in sodium chloride, discrete sodium atom and chlorine atom like these molecules are not present. Instead of that, it has a lattice like this made of large number of ions connected together. Because of that, since sodium chloride doesn't have discrete molecules, we use the word relative formula mass. Relative formula mass. Calculating it is the same way we calculate it. Now we can see that if sodium chloride is taken, relative formula mass of sodium chloride is sodium relative atomic mass is 23, chlorine 35.5. So 23 is 1 and 35.5 1. So you get the value as 58.5 as the relative formula mass. Relative molecular mass of sodium, then we use relative molecular mass of relative molecular mass of ammonia. Nitrogen is 17, hydrogen is 1, so you get, it has, hydrogen is nitrogen is 14, hydrogen is 1, so you get the value 17 there. So we use the word relative molecular mass for covalent compounds. We use relative molecular mass for covalent compounds, relative formula mass for ionic compounds. Here, this exercise is to find some relative molecular masses of some molecules and relative formula mass of some ionic compounds. You are given the relative atomic masses. So pause the video and do this and go to the next part of the video, and there I will show you how to do that. Before that, you copy down this and do this first and find all the answers and compare your answers with the working. First we look at the relative molecular mass of sulfuric acid molecule. Here 2 hydrogens are there, so 1 into 2. 1 sulfur atom is there, 4 oxygen atoms are there. So we get 1 into 2 plus 32, 16 into 4 is 64. So added 2 to 4, 4, 8, 3, 6, 9. So the answer is 98. The relative molecular mass of sulfuric is 98. Second one is urea. This is urea. So you can see in that molecule it contains 1 carbon atom, 1 oxygen atom, 2 nitrogen atoms. Since this 2 belongs to NH2, 2 nitrogen atoms, 4 hydrogen atoms. So that we can calculate it: 1 carbon, 1 oxygen, 2 nitrogen, and addition 2 nitrogen and 4 hydrogen. So 12, 16, 28 and 4. So we get 8, 8, 16, 4, 20, 1, 2, 4 and that to 60. So relative molecular mass of urea is 60. Third one is calcium carbonate. We know that calcium carbonate is an ionic compound, so that we use relative formula mass for that. Now here in this formula, 1 calcium atom, 1 carbon atom and 3 oxygen atoms are there. So 14 to 1, 12 into 1 plus 16 into 3. So you get 40, 12 and 48. So you get 100. The relative formula mass of calcium carbonate is 100. The last one is ammonium sulfate, an ionic compound. So to find the relative formula mass of ammonium sulfate, Look at the formula. 2 nitrogen atoms, 8 hydrogen atoms, 1 sulfur atom, and 4 oxygen atoms. So you can write 14 into 2 plus 1 into 8 plus 32 into 1 plus 16 into 4. So after multiplying you get 28 plus 8 plus 32 plus 64. 8, 8, 16, 20 and 22, 2 remains, 2, 3, 5, 5 and 6, 11 plus 2, 132. So the relative formula mass of sodium sulfate is 132.